হ্যাঁ হ্যাঁ দরকার ঠিক। হ্যাঁ দেখতে পাচ্ছেন, দেখতে পাচ্ছেন? হ্যালো হ্যালো, বন্ধ করে দিচ্ছি
না না, হ্যাঁ এই অডিওটা
হ্যাঁ
ল্যাপটপের কম্পিউটার বন্ধ করে দিন,
চালু করে দিচ্ছি। হ্যালো 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 চেক। হ্যালো
কি সাউন্ড আসছে না?
হ্যালো
অডিওটা সেটিং করে দাও, সেটিং নেই তো।
সেটিং করা আছে। হ্যালো 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 চেক। hello, 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 check, hello. 86.
কার সাউন্ড কি বলে?
Hello, laptop.
রেয়াজ,
Hello, hello.
আওয়াজ যাবে না, আওয়াজ। কেন একটা ভিডিও চালাও?
তুমি আছে
ঘুমায় স্যার আছে।
hello, 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 hello. হ্যাঁ hello, 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 check, hello, 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 check.
হ্যালো 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 ঠিক আছে। এক সেকেন্ড, আমি এখান থেকে অন করে নিয়ে মনে হচ্ছে। এক সেকেন্ড।
এখানে স্ক্রিন শেয়ার করা রয়েছে, ঠিক আছে?
এখান
কেটে দিলেন
থেকে
কোনটা?
না না, এই তো হ্যালো হ্যালো হ্যালো। এখান থেকে মাইক অন আছে তো? সেটা একটু দেখি।
দাদা হালকা একটু কমাও, আমি এখানে বাড়িয়ে দিচ্ছি।
অন আছে।
হ্যালো, 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 চেক।
হ্যালো হ্যালো জবে তাহলে সেখানে অন করতে
এখানে শো।
hello hello good morning students. হ্যালো 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 কি বলছো তো চেক করছি। আচ্ছা চশমাটা চশমাটা লাগবে, পড়বেন পড়বেন তো? হ্যাঁ হ্যাঁ পড়বেন না? চশমাটা হ্যাঁ পড়ে না। ঠিক আছে, চাইলে শুধু একটা
প্রফেসর সুভাষ ডাইরেক্টর অ্যাকুরেসি একটা চেয়ার সরাতে হবে। পিয়ুষ আমাকে দিয়ে কমলদা, পিয়ুষ কোথায়? আর হ্যাঁ, সবাইকে আসতে বলে, শুরু করবো। সবাইকে আসতে বলে ভেতরে। হ্যাঁ, রেজিস্ট্রেশন মাত্র দুজনকে রেখে চলে আসতে বলে। পিয়ুষ তাড়াতাড়ি।
হ্যালো হ্যালো, শোনেন?
ওইটা কে দেখ?
Hello student, am I audible?
ওই দিক থেকে এদিক থেকে। না, একটু দাঁড়া। আছে আমি ম্যাডাম আর প্রবিসি এখন তো আসেনি। আমি আর দাঁড়াবো না, তাহলে একদম শুনি দিই। পিয়ুষ, হাই, এদিকে থাক। পিয়ুষকে বলে সরিয়ে দিই।
Good morning, everyone. A very warm welcome to Physics Pulse 2025, the flagship outreach event organized by Department of Physics, School of Basic and Applied Sciences, Adamas University. We are absolutely delighted to share that this year, Physics Pulse has received an overwhelming responses, 320 registrations from over 20 schools across India. Your enthusiastic participation truly energizes our initiatives, and we look forward to spending a meaningful and inspiring day exploring the wonder of physics together. You know, physics is not a subject, it's a journey into the very fabric of reality. As a famous Carl Sagan said, somewhere, something, by Dr. Shattopadhyay Bhattacharya, Dr. Kaushik Mitra, and Dr. Naveen Veja. Today, we will begin the vibrant journey, and I, Dr. Papiya Dhara, along with Shamata Saha, Assistant Professor in the Department of Physics, am deeply honored to welcome our distinguished dignitaries, and I would like to request them to kindly take their seats on the stage. I would like to request Dr. Radha Goswami, Professor, Pro Vice Chancellor and Dean, School of Engineering and Technology, Dr. Moumita De, Associate Dean, School of Basic and Applied Sciences and Head, Department of Physics, Dr. Snehamanjur Basu, IQAC Director Professor Sobas, Dean Academics, Professor Dean, School of Life Science and Biotechnology, Professor Rutu Prasad Saha, sir. Please come on the stage and take your seat on stage.
Good morning, everyone. Good morning, students coming from various institutions. Welcome to Physics Course 2025, and I welcome you all. Welcome physics in your life. Love it, feel the mysteries and wonders of physics, and explore the universe. With this, let's start our program. Now, I'd like to request Dr. Moumita De, Associate Dean, School of Basic and Applied Sciences, and also Head, Department of Physics, to kindly deliver the welcome address. Please, ma'am.
Good morning, everyone.
A very good morning to all the students, all the participants, teachers, respected dignitaries of the dais, on the dais, and our esteemed speakers. Thank you very much. Every year, we try to make some initiatives with our Department of Physics, and this is no exception this year. So this year, we have already started the program online. Those who have joined yesterday, I hope you all enjoyed. It was about exploring space. It was about the speakers who worked in NASA and ISRO. They have shared their experiences. And today I'm equally confident that this is going to be another exciting session where you will get to know, get to learn, to gather some insights from our industry experts, academic experts from various domains. And at the second session, you will be able to learn through hands-on training about AI/ML, about Arduino. So I'm sure that it's going to be a very, very special and exciting session for all of you. And thank you for joining us. And it's not about Adamas University. It's not about Department of Physics, Adamas University. As I said yesterday, it's about physics. So let's learn, let's enjoy the session. And I won't waste much time. So thank you very much for joining us offline. And we will start. Thank you.
Thank you, ma'am. Thank you for your kind words. Now, I request Professor Dr. Radha Tamal Goswami, Pro Vice Chancellor and Dean, School of Engineering and Technology, to address the gathering and inspire the budding young minds before us.
Thank you, Samuta. Good morning to all of you. I could see many students from 11 and 12 are here. So that is a great thanks to Moumita, our Associate Dean from the School of Sobas, as well as the Physics Department, Professor Snehamunju Boshu, our Dean, as well as the Director IQAC, and Professor Rutu Prasad Saha, the Dean of Academics and Dean of SL. I, on behalf of the Adamas University and very specifically the Department of Physics, welcome the speaker. Yesterday, I was also there present in the online mode. So it is really a great things your physics department is doing to actually energize the students' young minds on the physics, how to explore this one. And they have divided the speaker in such a way that yesterday is a completely and the science faculties were there, and today the composition is from the computer science and engineering. So that is the pure blend of your science as well as the engineering, because engineering cannot stand without the science if you do not know the science. I know Dr. Tanushyam Chattopadhyay, who is a speaker and who is in also Hari, because for a long period of time and is an excellent speaker, and the other speaker is also good for this today. And this is definitely is a very good for the young mind to energize yourself for the different your subject matter. So I hope it will be an interactive one and good one. Thanks to the team of physics for organizing this one. My best wishes to all of them. Thank you.
Thank you, sir. Thank you for your insightful thoughts. Now, I'd like to invite Professor Dr. Snehu Manjubashu, Director IQAC, to share a few encouraging words with our students.
A very good morning
to everybody assembled here today in this beautiful gathering. At the onset, I like to extend my heartfelt thanks to Dean Sobas, Momita, because this is really an excellent experience for me. This is for the first time I am joining this type of program where there are so many young faces I can see in front of us. And I have heard that they have come from different schools across the country. So really, it is a great opportunity for us. My respected Pro Vice Chancellor, Sir, respected Dean Academics, Dean Sobas, respected professors, all the dignitaries of the dais, on the dais, and today's eminent speakers. On behalf of the Quality Assurance Cell of Adamas University, I like to extend my heartfelt welcome to all of you. It's really an excellent effort from the Department of Physics, I should say, that they have gathered so many young minds to attract to the physics. And I think without knowing anything about physics, everybody will feel wonder when we look at the sky, the stars. And I'm sure after 26 June, after Shubhranshu Seal's expedition, all of us feel really attracted to the space research center, space research thing. And we all know that ISRO, Indian Space Research Organization, are doing marvelous tasks in this domain, starting from 1920s. So, young students, I think you will be really benefited from this workshop, from this today's program. Yesterday was an online program. I think you have enjoyed a lot. Today, you have some eminent speakers, and also you will get hands-on training on physics. We all are interested about knowing the stars, the space research. So after this successful completion of the workshop, I am sure that you will feel more interest in physics, which is the mother of all science. So wishing a very happy stay in Adamas University, and I wish the success of this workshop. Thank you, everybody.
Thank you, ma'am, for such motivating words. Now, I'd like to request our Dean Academic Sir, Professor Dr. Rudra Prasad Saha, and he is also the Dean of School of Life Sciences and Biotechnology, to share a few words with us.
Thank you. Very good morning to all of you, distinguished speakers and guests on the dais and off the dais, and the students and faculty members. So I would like to share a couple of personal notes related to physics. So the last time I studied pure physics in my class 11-12 in 1995. So none of you are there at that time, the students specifically. But after completion of my higher secondary, I was from West Bengal board. I wanted to pursue physics honors. Okay, but for certain reason I could not. And then I pursued biological sciences field in undergraduate, and then but my love for physics was there, so I pursued a kind of combination of physics and biology in my masters. So like biophysics from Calcutta University, and then my PhD is not in physics, but my love for physics was there because I always wanted to pursue physics honors. Because of a couple of numbers, I could not get selected in some premier institute, so I pursued biology. So at that time, so like 30 years ago, relevance of physics was there. Right now, many of the students probably looking for applied fields.
Thank you, sir, for your presentations. And thank you for some appreciation.
Okay, so let me share the program schedule after this program. So before that, I would like all the dignitaries to please take your seat. Thank you, sir. Thank you, madam. So today there will be two. One is first is by Dr. Tanushyam Chattopadhyay, and the second one is by Professor Ananda Dasgupta. And break, there will be two parallel workshop session. One is on machine learning, which will be heading by Dr. Pradipta Kumar Banerjee. And the second one is workshop on Arduino, which will be heading by Dr. Ram. So now, without delay, let's dive into our first lecture session of the day. And we are honored to have with us Dr. Tanushyam Chattopadhyay, who will be speaking on career prospects of physics graduates in the academic and industry. It is my absolute honor to introduce our distinguished speaker for the session. Dr. Tanushyam Chattopadhyay is currently the practice head of computer vision at Sirius Digitech, with decades of experience in the cutting-edge technological research and industry innovation. Dr. Chattopadhyay began his academic journey with a BSc in Physics from Vishwabharati and went on to learn his MCA from Bengal Engineering College, where he was the University Gold Medal. Agency Services Innovation Lab of 8.64 video
share. Yeah, এটা বন্ধ করতে হবে। Close, close, close. Sir, আপনার
This is clear, but
এটা দিয়ে খুলছে না কেন?
control টা মারতে পারবেন না।
হুম। হ্যাঁ।
Control দিন করে।
কেন? ঠিক আছে।
না, না, best of luck.
স্যার এখান থেকে চেঞ্জ করতে
Okay.
পয়েন্টার দিস স্যার একটু পয়েন্টারটা চেক করেন স্লাইডটা চেক করেন
I believe I am audible till the last, as well as whoever on the other side in online, I'm audible. Am I correct? Please ensure that my slides are also visible. Okay. So, first of all, let me thank the dignitaries and the organizers who invited me here. And let me address the audience today as my children, as my son himself is a student of class 11 and he is also willing to pursue his career in class basic science only. So that is something what I'm going to present today. I mean, my fellow guardians are there. I mean, maybe in some other day we may meet in front of some school or college gates. So I see some of the faces there as the guardians. So it's something very interesting session that what I usually speak to my son, I'm going to tell you today. So this is something that roadmap for physics graduates and masters, how they can excel their career. I'm absolutely focused and try to make it very target oriented and what steps you need to do. I have already shared my slides with the organizer so that you can get it. And here I made it like this, that step 1, step 2, step 3, step 4, like that. So what are the sectors where a normal physics graduate can go? There are 4 areas, absolutely 4 areas. Academic research you can go for, government and public sector, corporate IT and finance, and teaching, and new term is the edutechs. Who is edutech? So let me go one by one. In academic research, like whoever are your faculties here, they are something like lecturers, professors, research scientists. And I know that second half, I mean, some other people will speak who are from the academia. They will speak that how to PhD, fellowship, I mean, space science, all these places, how we can work. Second is the government and the public sector. So different government organizations also recruit. When madam was speaking about ISRO, definitely ISRO is a placeholder for the physics graduates. Apart from them, another big sector where in India at least any physics graduate can go is the BARC, Bhava Atomic Research Center. So these are the 2 sectors. Third, I'm making a change in the ordering here. First, I'm speaking about the EdTech. You all have heard about the FIRSI, BYJU'S, etc. And possibly, I mean, many of you are trying to take your coaching there to excel your career in IITs in future. But even after going to IIT, you can again come there also you can study physics. On the other hand, I know certain faculties from such EdTech who are IIT alumni, but they ultimately from engineering, they come to teach physics or mathematics. So definitely that's also a career path, particularly in the year of 2025, when everyone is aware of Khan sir's class or physics wala. I don't say that only career path is to go for teaching. And last one, but not least, is me, corporate IT and finance. Once upon a time, I studied physics. That's why I was telling one of your speaker in today's second half as my junior there. So I realized some dignitaries were speaking that, I mean, he found that he didn't got good score. I found it myself. Hello, yeah. So what I realized the other way means I didn't opt for engineering after my class. I'm also Bengal board student, means higher secondary, HS. So after HS, I didn't opt for engineering because I had a passion for physics. I started to study physics, but after entering into the MSc 1, I realized that I stood some rank in university. I stood third, but I don't understand anything about quantum mechanics or some other aspects of physics. So it was a big dilemma for me, whether I should proceed what I don't know but getting marks, or I should think something. So that time I got an opportunity, like these sessions, this physics pulse or this university was not there that time. But incidentally, for being a university top 3 rank holder, I got an opportunity to attend a class from IUCA. How many of you heard of IUCA? Very good. So another basic thing that wherever you go from basic science or anywhere, you will be very updated with the current affairs. Who was the founder of IUCA, who passed away very recently? Famous scientist. Anyone? He passed away very recently, and he was founder of IUCA also. Yes, ma'am. So, answer, it came from ma'am. If it is come from student, I'll take this microphone there, but came from madam. So, it's obvious that it will come from here. Jayanto Vishnu Narlikar or JVS Narlikar. So, very proudly, I can tell you the story. It was a winter morning in Shantiniketan. You all aware of Shantiniketan, where I was in charge of these conferences. That conferences, I was in charge of the car travel transportation, and he knows Oshim Roy was that his friend was he was the convener of the conference. So I was insisting professor to come to car, and he's telling no, I will walk. So after that, he initiated a course for the the IUCA astrophysics course there, and I got chance to be a participant there. What happened? One professor came there, Professor Shomok Raichaudhuri. He informed me that applied physics, if you can think of doing some programming. So I started lots of concentration on programming because in Vishwabharati that time programming was part of our curriculum. And from there, I landed into Shipur, later ISI, and right now doing serving in AI. So that's the path where I traversed. And if I tell this is the path, that's all. I can conclude readily here, in fact. But nowadays, the path may be more sophisticated or more structured way. That's why let me take you through different these paths. First, start with the self-assessment. Before coming here, I mentioned about my own journey. After scoring good marks, my self-assessment told that I am getting marks, but I am not feeling that much interest in quantum mechanics. So first thing, introspection. Normally, as a guardian, I mean, can see some of the guardians' faces are also here. The problem of today is that everyone is trying to showcase him or her as a very good student. For that, two things are coming very frequently. One is credit snatching, and second one is the blame shifting. Credit snatching is something like that. I had scored that much, but my friend got better, not because of his credit. Madam or teacher may like him more. But just because of that day, someone from my back, he told me that's why I could not perform it. Stop it. Spend some time for self-introspection. Introspection or that self-assessment is the same thing. That you realize your potential, what you can do, what you cannot do. Be very honest to yourself. And that's the beginning of your career path. Based on what your mother says, what friend says, what friend's mother says, don't go for that. Listen very carefully what you want to be. Don't do anything else. It will land you into a very big trouble in future. Because I have seen most of the students who came to study something or engineering from maybe he loves physics but went to engineering, they ultimately landed in a very frustrated stage. That's why I tell you, listen what you want and try to assess yourself, not using your Facebook likes or Instagram comments. You may get so many followers in YouTube, YouTube, Insta or Facebook, but that's not a good credentials. Assess yourself carefully. And that's the basic step of getting anything good in the career. I realized it with my age. That's the first step. Second one is the reflect on work preference. Consider, for me, it was absolutely, I loved experimental. I mentioned it also. And that's why Professor Shomogra suggested me to do programming there. Incidentally, most of the curriculum, whatever is adjusted all across India, not only India, abroad also, is mostly theoretical based. Theoretical foundational physics is one aspect. On the other hand, practical is other aspect. So if someone likes practical, try to know from day one. Right now, that time when I graduated, that time no Google was there. But you can search what is happening in CERN. CERN. CERN, what is happening there? Start searching. What is happening across MIT, Stanford? Knowledge is now open. Geography is not a barrier. Your marks is not a barrier. Only barrier is you, your mindset. If you can evaluate, you are a theoretical or experimental, you can go that side. And set clear personal goals. Establish clear goals based on your preference. Effectively save your academic career direction. So 4 paths I mentioned earlier. Now, based on your choice, you can select what you want to do. Now, how you can go for higher studies. There is a only way to get higher studies is reading books. Not books means that physical books now, study materials. And that's why the image is generated. It's not drawn by me. AI generated the image, but my prompt was something. Graduation hat should come on top of the books only. So not we are graduating, whatever is studied, that's got the graduation degree actually. So you can see here, academic research pathway, pursue MSc and PhD physics, research on academic areas. Here SINP, VEC, all these places are there. And attend, ISI, IISC, all these places are there, IITs are there. Applied and interdisciplinary options. That is something most emerging in globally now. Means physics along with some computational physics. Physics along with geography, geophysics, even biological. I'm very happy that I heard today only here that this university started some course on this similar type of course, that the healthcare, oncology, and physics. It might be an excellent option. And For that, for higher studies, I have listed also for you because I'm telling that I'm treating you as my children only because I had to do this homework for my son that like GATE, JAM, GRE, JEST, CSI and NET, these are the exams you have to sit for. Clear? Now, align your career goals. So for that, I know that the speakers in the second half will speak on our professors, maybe from Future and Taki Government College. They will speak about the career path in the academia, more details I believe they will speak about. That's why let me take you to the path where, yes. So what you need to do, 1, 2, 3, 4, 5, 6. I initially requested for a board, but rather I prefer you to take notes. Do you have everyone a pen and paper? Okay. So if now I'm absolutely focusing towards and make sure that I will take at least 5 to 10 minute sessions absolutely dedicated for you for the question and answer. Okay. So you can hold your horse for a while in a stable mind because horses are kept in the stable itself. That's why I'm telling that keep your mind stable and keep your horse in the stable so that you can take a note. So if you want to excel in the path of data science and AI, what you need to do? Now it's an era where 3 things you mandatorily need to know. First, English language for communication. No need. I mean, they are taking notes. That's the best thing. Second, mathematics as a communication. I mean, Madam was telling that physics is the mother of all sciences, but mathematics is the language of all sciences. So I'm speaking about 3 languages of the recent era. You must know. One, English for communication. Second, mathematics for the communicating science. Because nowadays, I mean, even in my family, though luckily I'm surrounded by most family members are from the physics background, but whenever I'm telling that for all, that's all, I mean, for all this notation, so many times I'm using even in day-to-day communications, means I'm very frequently say that it is mutually exhaustive interest, mutually exclusive interest. So something like that very commonly comes is whenever I'm talking every day for my research work or translational research, rather how to convert it to a real product, you need to know what is the mathematics. And third language, what is the third language? Is the programming language. Programming language, possibly, I mean, you are from CBSE and ICSE board mostly. Am I correct? So for that, you are learning possibly Java and Python only. Prefer to use for AI, use Python, but for the front end, you can use Java, Angular, React. So previously it was you need to know all, now you need not to know all. There are some software tools, AI tools like Figma, Figma. What can make the user interface very easily? And it will export the code into Angular, React, or JS. So for Java, you need not to focus that much. But for problem solving, I suggest to go for Python. First 3 to 6 months time, during your time of graduation, you should spend to learn first 1 semester, I can say. It's a normally how many semesters are there? In graduation now 8 semester or 6 semesters still there? 8, yes. So first semester spent for learning Python. Second semester or second and third, you should know how to use the Python tools like pandas for visualization, matplotlib, all these tools you have to know. Second and third semester complete. So you now, right now, you know Python and you know some Python libraries, how to use it, how to make a visualization. And during your, assuming that during up to your class 12, you have already learned Java, JavaScript, and using Figma, you can now make the user interface. Now, by the time you studied a lot of physics, Am I correct? Till third semester, you have learned lots of physics. Now start thinking, how can you convert this to, I have written all these things, you can read it here. Means whatever I'm telling, I actually cannot read for my slides. That's my very bad thing. That whenever I'm speaking, I know that whatever I have written, I have only written it. So you see that Python, C++, MATLAB, I options are given, data handling, Excel, or SQL, one thing I missed, and the NSR communication with clear presentations are start from there. So these are the three skills that you need. Yes, so I'll come at last. Okay. So now, next what you are doing, you start doing some, I request organizers to share at least my slide deck with all the participants, please. Means I believe free of knowledge. So you can upload in the website also. I prefer actually. So you need to take photo from here, okay? Please concentrate. So next one is that start burning your hand on solving some real world project. By that time, you know what is happening in your electronics classes or your modern physics classes. You have lots of instruments. Can you write a code? Nowadays, generative AI, even ChatGPT is there and OpenAI is there. And by that time, it will be matured even bit more. Can you take data? In our days, we have to take notes in the notebook for the all practical observations. And then we have to write the report for our practical classes, isn't it? You also did it. Means you are almost 10 years younger than me, your next second speaker. So we also used to do it. But now, can we think with this advance of AI, can we write something that lab report generator? From my notes, it will take the reading automatically. Or whenever just you're in your class 10 also or class 11 also, you have already completed your the experience with pendulum. Is it? Is a L versus T square graph. Am I correct? So for L versus T square, can you do one quick experiment? Instead of doing you're noting the stopwatch, can you run something? Your mobile phone, can you capture the image or the video and write a code that can detect what is the exact time taken for that? What happens? The problem of your school or anywhere is that the time you can get is the 1 second. That's why normally if you get 976 or 980 is absolutely wrong answer you got. Means you did some manipulation. Otherwise, no one can get something like either 940 or 1020. Isn't it, Professor? It is Professor now. So I am asking Professor here. So it's a real experiment, means if you do it. But can you ever try by using your mobile phone, capture the video and try to do some code which can detect what is the exact time period? It might be very interesting for you. This is very simple, what you can start with, but in your graduation classes, you can have more AI problems. Start working on those problems till 6th semester. Now 7th and 8th are remaining. First, only programming language, Java. From Java to Python, it will take not more than one. Next 2 semesters, third and fourth, second and third was for the pandas and other libraries, whatever mentioned, SQL. And fourth, fifth, sixth for doing some hands-on practicals and develop some codes. But whenever you are developing the codes, how world will know? Like immediately after going back here, I request, my Artida, means your vice chancellor here. So I'll ask to share some images with me or organizer so that I can post it in LinkedIn. But how your code world will know? Any idea? You have to upload it in Kaggle or GitHub. So from now, start do the practice that create your account in Kaggle or GitHub so that you can upload all your codes there. And world knows not by your face, not by your anything, but just by your codes itself. Done? Now 7th and 8th semesters is pending. Unless and until you have some clear certification, no one will acknowledge you as a knowledgeable person in AI, though you have already learned it. So 2 courses I can recommend from Coursera. One deep learning, and another is the Andrew Ainge. Most of the people tell him as Andrew Ainge, but I'm really fortunate that I met and had a discussion with Andrew in 2015 once and 2018 once. He pronounced his name as Andrew Ainge. Okay, so you have to take these two courses as per today, I can say. Maybe in future some other things may also come. Coursera courses you have to complete, one for deep learning, one for Andrew Ng, basics of machine learning. Apart from that, I strongly recommend to go through the book by Ian Goodfellow and Joshua Bengio on deep learning. Particularly chapter 1 and chapter 5 should be completed before your graduation is completed. Now you are ready. Then if you want to pursue your studies for computer science or something, you can apply for ISI MTech, or you can go to IIT for MTechs or IISC. And I have already mentioned, if you want to go abroad, what are the options? GRE, TOEFL, or you can apply somewhere abroad. Update your profile religiously in LinkedIn, and Internshala, like Pathshala earlier was the schools. So now Internshala is that place where you can get internship, and different other companies like, I can speak some of the names, like my earlier organization TCS, Wipro, they recruit from some basic graduates also. So you can apply for internship there also. So now, by that time, I mean, my last slide you can remember, this slide is the only slide I can say that for the 11 students, the most important factor is this one. Yes. So that is something you have to complete by that time. What these three things? Internship, boost skills with internships and project, internship for practical experience, mini projects, competitions for wider exposure. Many universities organizes these conferences and these hackathons and these codings. Go participate there, and remember that participation is important. You need not to justify that your failure to your parents. Smart India Hackathon is a great event organized by Government of India. Try to participate there. Now its microphone is over to you. Any questions? I love to take. No question. So it's a 0 or 1 rule. Means you understand everything or nothing. I don't know what happens. Actually, I covered this slide mostly all around. So slides for your, I mean, reference for the future study. But what I mentioned, that is something as per my experience. Anyone from students or guardians? Please.
Good morning, sir.
Good morning.
Sir, I want to know how can I pursue AI from physics honors?
Exactly, it is written. Take a photo.
A little bit elaborated.
Little bit elaborated.
Yes, sir.
You see here that exactly what I told is the path to journey for AI only. AI is artificial intelligence. For that, what you need to do is that exactly this. First one, they build a strong foundation. So what is written here is that begin learning Python. I mentioned about how to learn Python. Second, create and share projects. Earn certifications. I mentioned Coursera courses. And fourth one is the advanced professional roles. Once you get some internship, you have to, I mean, apply it for the higher positions, or you can go for higher studies. Exactly, that is, I mean, explained all through the path is that only this one.
Sir, I am talking about that I am currently pursuing physics honors, second semester student. But after physics honors BSc, what can I join? MTech or any master's degree in AI?
Preferably, if you want to go for AI, the first thing that you ask yourself, if you are committed to go for AI, go for some masters in AI, preferably from IISc or ISI Kolkata. Chennai IIT course, I cannot encourage that much, BSTS.
Thank you, sir.
Or the course path, I mean, you can get in the slide text, all the course paths, all the university names, everything is there. Oh, what are the about? Works. Then you can speakers should take the same microphone.
So during the COVID time, I just tried to develop some Python-based virtual laboratories where I can simulate the physics experiment. Because in the COVID time, the student cannot do the experiment by their hand. So practically, I developed some environments using Python. And someday, one of my fellows said, one of my faculty says, you should not do this because the student will be habituated to do their experiments by in the virtual mode. So actually, they will not do something by their hand, and their actual skills for the practical skills will not develop. And maybe some days the laboratories will be,
obsolete. Absolutely abolished, but I mean, I'm just love to again remember one of my proud moment. Professor J. Pullman got Turing Award in 2020. So similar type of question I asked said that automation may kill lots of jobs. So what is your perception on that? So it was a nice morning in Chennai, 2015. We are having breakfast together. His comment is that Tanushyam, you cannot stop automation. Similarly, virtualization, you cannot stop it. It's like a bulldozer. You have only two options. Either you have to be the driver or you have to embrace it. Otherwise, you will be succumbed with it. And in the 10 years from 2015, it's already established. So hardly there will be any students in future you will get. It's something mental block. And in nowadays I'm doing some course in IIM also. So in terms of management, this is a resistance to change. Change is unavoidable. This is some resistance in the mindset. It will come, but time will prove that there is no way. Someday people will install some cameras only. They will swing the pendulum. So that's why I'm telling that don't go for automation. Don't go for the traditional approach. Make a proper blend between this. And I always say that if this is machine, this is human, make a proper handshake between them. Don't make it absolutely virtual. Don't make it absolutely traditional. Let them give the opportunity to compare their results with AI. They will evaluate which one is better. Yes, one more question, please. Please start with your name and from where you come.
Good morning, sir. I'm Rafael from class 11, Adamas International School. I wanted to ask, sir, do our generation or the world need innovation or invention in today's generation? I'm just asking.
That's a very tough question to answer, really. Very good question, a very tough question. That to define the difference between innovation and invention. So something is that I can say what is target oriented and something is that for pure doing research. Just I can say that let me take one quick example because Oppenheimer was a too many award-winning movie. I believe all of you have seen. So when Rutherford broke the atom, it was an invention. And when Oppenheimer built that atom bomb, it's innovation.
So I think I'm just saying that. Like,
I'm telling.
Yes.
Now let me come. Invention is absolutely required for making any innovation. But innovation requires one most important thing is that it should be in the good hand. People of the good people's hand, it should be there. Otherwise, totally misuses can happen. So in your generation, Gen Z, in your jargon, you are Gen Z. So you are most focused towards innovation than invention. But definitely some foundational invention must, like I can say that you can make a good mobile phone or good some electronic device, but it will not work if the battery life cannot be getting longer. So for that, some foundational research is also required. And the same answer what Ramaprasad asked, your next, speaker asked, is again coming here, that again, that same blending should be there between innovation and invention. Some of you, definitely being Gen Z, will come to innovation, some will go to invention.
So I wanted to ask that like 20th century was home to many inventions rather than 21st century. So can we expect that there's like 90% inventions are all done in today's
Not
21st?
absolutely contradicting here, because a big leap is going to come for where the physics students may need to contribute more. ETH already came out, China already came out, it's the quantum computing. The basic change in paradigm is that whatever is now machine learning and AI are using is a discrete distribution based. Means it can, first thing, that analog data it cannot process. First of all, you need to convert the analog to digital. For that, we need to go for quantization. Once we do the quantization, it comes to the basic mathematics jargon. It's a, I can say it's a discrete distribution estimation. But whenever quantum will come, more qubit and the more storage and more computing power will come. What it will lead to? It will lead to the continuous distribution. So massive change will come at the time. And another, I can tell you the another aspect, that whatever the security measures and cyber security and others are there. So for bank, it's a two-way authentication. OTP is coming. OTP is algorithm everyone knows. But the fact is that all the OTPs are valid for 2 to 3 minutes, isn't it? The fact is that no computer can, knowing the algorithm, also cannot crack it within 2 to 3 minutes. But if the first day computation comes, then OTP will be no more valid. All cyber security will be at stake. So for that, invention is again required. All transformation, Laplacian transformation, Adamas transformation, I'm telling a bit technical words now. So it will be totally moved from discrete phase to continuous phase. So I cannot say that invention will be stopped.
Thanks.
Any more questions?
If you have any more questions, I'm very much available in LinkedIn. Normally in weekends I reply. Maybe in 2 weeks and you can get my reply. And my name is Tanushyam Chattopadhyay. You can get me in LinkedIn very easily. Oh. You were in which class?
Time.
Oh, 9. Very good.
I am actually trying to develop an app for people with ADHD, and for that I require to develop an AI. What according to you is the best course for high schoolers to develop an AI?
You are not high schooler. You are totally advanced. Nowadays, stop the barrier of the age. Whatever you have learned is really advanced. You can directly jump to Android's course for machine learning. And the book I recommended, you can go for that also. Okay. Goodfellow, Ian Goodfellow, Good, G-W-D, Good, F-E-L-L-O-W, Deep Learning. From MIT publication.
Thank you, sir.
Oh. So then you can get the soft copy from me. You can ping me, I will share you the soft copy then. The soft copy is in my mobile phone itself. Better to go for mother first, then come to father's profession. Then I recommend that because it will help you in future. Otherwise, I have to stop here. Physically, but virtually I'm available in LinkedIn. I have some stop card because of my corporate commitment. So thank you all. Again, it's a nice interactive session for all participants.
Thank you, sir.
It is a clap for me. I request you again to clap for the participants. Thank you.
Thank you so much, sir, and for such enlightening session. and it's truly helped to break the myth surrounding that limited career prospect for the females. So now actually it's time to extend our heartfelt appreciations to our esteemed speakers and resource persons to the formal felicitation. So first I would like to request Professor Radha Goswami sir, Pro Vice Chancellor, Adamas University, to felicitate Dr. Tanushyam Chattopadhyay.
Good that the crowd is coming from class 8 onward to great graduation.
Thank you, sir. Sir, I would like to request, please take your seat. Now, let me introduce our esteemed resource person today in the workshop session, Dr. Pradipta Kumar Banerjee, sir, who will be leading our machine learning workshop session today. Dr. Banerjee holds PhD in image processing and pattern recognition. His research spans computer vision, neural networks, and deep learning, with over 270 citations highlighting his significant contribution. Now, I would like to request Dr. Aparajita Bhattacharya Madam to kindly felicitate Dr. Pradipta Kumar Banerjee, Professor and Head of the CSE AIML Department at Future Institute of Technology. Kindly come sit in the center of stage. Thank you, sir. Thank you, madam. Please take your seats. Now, I would like to introduce our second resource person, Dr. Ramaprasad Adam, who is currently Assistant Professor at Department of Physics, Taki Government College, and his PhD from University of Calcutta in 2018, and specializes in experimental nuclear and high energy physics. With over 300 citations, his research on GEM detectors and radiation studies has been widely recognized. So today he will guide us through the Arduino-based hands-on sessions. So now I would like to request Dr. Momita De, Associate Dean, HOD, Department of Physics, to felicitate Dr. Ramaprasad Adho, sir. Thank you, sir. Thank you, sir. Thank you, madam. Please take your seat. I would like to thanks all of you, and we are really truly honored to have such immense resource person with us. And I would again once again thank them for their time and dedication. Our next speaker will come almost in 2 to 3 minutes. So let's wait for some time and then we will start our second lecture by Professor Ananda Dasgupta. Please. I would like to inform that our next speaker, Dr. Ananda Dasgupta sir, is with us now. So first of all, I would like to welcome sir, welcome madam, Adamas University. So first of all, I would like to request Dr. Momita De, Associate Dean Sobers and HOD Department of Physics to come on the stage to felicitate Dr. Dasgupta. Thank you, Professor Dasgupta.
ডক্টর দেবেন স্যার ডক্টর দেবেন তো ওটা ডক্টর মেল করে দিয়েছো হ্যাঁ আছে রাখা আছে আচ্ছা আর কথাটা লিখ না বা তাহলে ঠিক আছে ঠিক আছে লিখিস স্যার এটা এইটা কি না এটা তো নয় আচ্ছা এইটা টিএমসি স্যার এটা তো স্ক্রিন করে দিন কন্ট্রোল এল করলে দেখা স্ক্রিন শেয়ার করতে এই মাইক আছে আর স্যার অনলাইন স্ক্রিনটা শেয়ার করে
Hello everyone. Hope after this short break you are a little bit refreshed now. So we are honored to have with us Professor Ananda Dasgupta, who will be delivering the next lecture on how the quantum can keep our secrets. So Professor Dasgupta's research spans several exciting areas, from investigating gravitational singularities using the Roy-Choudhury's equation to exploring phase transitions in liquid crystals and applying linear algebraic techniques in quantum optics, particularly in squeezed states and matter radiation interactions. He received his PhD in physics from Jadavpur University and has held academic positions at St. Xavier's College, Jadavpur University, and IISER Kolkata, where he currently teaches and mentors young physicists. Recognized for his outstanding contribution in science education, he received the IISER Teacher Award from the Indian National Science Academy in 2023. Beyond academia, Professor Dasgupta is also a passionate science communicator. He runs a popular YouTube channel where he simplifies complex physics concepts for students and enthusiasts, inspiring a broader audience to engage with the subject. Let him give, sir, please you start.
Yeah, thank you. Will I use this or?
Sir, which one you're comfortable with?
Okay. I'm audible, right? Okay, thank you for this very kind introduction, somewhat exaggerated, but still. I must thank Adamas University for holding this wonderful program. I'm visiting this particular campus after 8 years, and I was very taken by the beauty of the campus last time. This time, we have not been able to see the campus that much, just enter straight into this auditorium. But I do plan to go around. I'm sure it has improved over the last 8 years. Now, before I start, so what is the language to be used here, English or Bengali? English is okay. Sometimes I might lapse into Bengali. I'm not very sure about that, but still. Okay, now English is good because we will start with an English story. So as you can see, the title says secrets. And secrets, of course, where do you have secrets better than, say, detective stories? So now I'm not very sure whether this generation still reads Sherlock Holmes, but this is not working. Anyway, it doesn't matter. Yeah. Let me just check whether the pointer is working. The battery. Oh no, it's not switched on, right? Disconnected. Is it switched on? Maybe it doesn't matter. I can just do it from here. Yeah. It's okay. Especially the pointer. Yeah. Thank you. Okay, so I'm not sure how many of you have read this story. When we were children, we used to devour Sherlock Holmes like anything, but I'm not sure that's what young people do nowadays. But let me just quickly tell you about what this story says. Basically, this is about a person who comes to visit Holmes with a rather weird complaint. All over his house, suddenly there are chalk markings of, say, things which look like children's drawings, some squiggly men. And of course, the person initially ignored them completely. But whenever his wife got to see those men, the pictures of those men, she became very, very
frightened and sick. So he thought that there must be something very strange going on, so he came to consult Holmes about it. And this was the kind of picture that was drawn. So this is the dancing man. Okay. Now they can, of course, make out this is actually a coded message. Some kind of code is being written down here. And the important point is this code was actually used by a gang in US. And the wife happened to be a member of that gang also, who has, of course, escaped from the gang and is no longer in that life. Now, here, I'm not going to read the whole thing, but what's important is in the end, the lady is grievously injured, and Holmes actually writes the message in this same language, calling Abe Slaney, the person who wrote that message, to her house. So basically, in order to trap him. So the important point here that you have to look at is the last line. So this person was very concerned as to how somebody else could have possibly written the same message or message in the same language. And Holmes replied, what one man can invent, another can discover. Okay. Now, this is basically the story of codes and code breaking. Right? Codes can be created and they can be broken. Now, I could go on talking about other stories like, say, Edgar Allan Poe's Goldbug is a very famous story, which I would recommend to all of you. And in Bengali, there are wonderful stories as well. I'm pretty sure from Tagore to Satyajit Ray, everybody has written stories about codes. But I'm not going to lengthen that too much. So I'm just going to move on to this. So this was a machine that was used to code messages by the Germans during the Second World War. It was called the Enigma machine. And it was supposedly unbreakable. I'm not sure anybody here knows who this is. Anybody? I don't think anybody would know who this is. But anyway, people should know who this person is. There's Alan Turing. Alan Turing led the team which actually broke the Enigma code. Okay. The story of breaking the Enigma code is a very long and complicated story. There have been at least 2 Hollywood films made on that. And apart from that, the original books are even better. You should read the books. They're very, very interesting. But the lady in the middle happens to be Vera Atkins, one of the leading spies in the English spy pantheon. In fact, she was part of the team which actually managed to smuggle an Enigma machine out of Poland before Poland fell to the Germans. Actually, the Polish Secret Service had actually captured an Enigma machine. It was stuck because Germans had already attacked Warsaw. So Vera Atkins and a team of people went in and brought out that particular machine, which actually was why in the end they could actually do this breaking of the code. Well, Vera Atkins also has featured very strongly in a recent film. Again, I'm not sure whether youngsters watch spy stories any longer. There was a recent, maybe 3 or 4 year old film called A Call to Spy, where Vera Atkins was one of the major players in that. And what's important for us Indians is that one of the spies whom Vera Atkins later, in the middle of the war, sent into German-occupied Europe was Noor Inayat Khan, the most famous Indian spy of all time. Anyway, that's a different story. Let's move on to modern codes. Most modern codes actually happen to be based on something called public key cryptography. In fact, it's weighed a lot of maths and very little intrigue. It's more maths than anything else. It's called this particular cryptography protocol, which is what is the basis of most modern codes, is called the RSA. And the reason is obvious. The 3 people who actually invented this, and officially invented this, is Ron Rivest, Adi Shamir, and Len Adderman. Their names, their initials gave us RSA. Actually, again in the middle of the war, somebody in GCHQ, which is the British headquarters for spying, actually had invented the RSA, but that was classified. So by the time it got declassified, RSA's, this reverse Shamir-Adleman algorithm had already been published. So despite the fact that somebody else did this 30 years ago, 30 years before RSA, still this goes in the name of RSA. Now, the mathematics of RSA is actually very fascinating. Again, that would be one more whole hour of lecture. But let me just point out one very important thing. Why is this so powerful? Why is this code so hard to break? And the idea is this. When we were children, one of the worst things we had to do in maths was factorize large numbers. And frankly, our parents and the teachers used to consider us dummies when we couldn't do that. We usually failed rather miserably, and they sort of told us that every dummy can do that, why can't you? It turns out that factorization is actually prohibitively difficult. It's one of the most difficult problems that we know in classical mathematics. When I say factorization, I mean factorization of really large numbers. Large meaning 200 digits, 400 digits, that kind of large numbers. So roughly speaking, factorization sort of scales as a 3/2 power of the size of the number. That's really not accurate. It's sort of an approximation. That's the most efficient algorithm that we have. That's the one thing that can be worked out fast in the least amount of time. However, say if we today breaking a 240-digit semi-prime, a semi-prime is a product of two primes, two large primes. Factorizing a 200-digit semi-prime is something we can do now using our current computer strength. And because we can use distributed computing, etc., it takes maybe a month. Or even nowadays with more stronger instruments, maybe a day. But that's for 240 digits. For 400 digits, that would take, if you scale it by the same way, you just divide 10 to the 240 by 10 to the 200. That's already 10 to the 400 by 10 to the 200 is 10 to the 200. You raise it to the power 2/3. That's a huge, huge number of days. So huge that it's way more than the age of the universe. Okay. So all modern codes actually survive primarily because of this. Factorization is extremely, extremely difficult, at least through any classical algorithm. Okay. Now, there's one more thing which has to be said here. Okay, I will come to that later. Let's just move on to this next topic. But what made this somewhat easier, at least to us, was the fact that you could use quantum ideas to actually do calculations which you could not do using standard classical approaches. Now, again, the person who first talked about quantum computation was not really talking about codes. Richard Feynman actually was talking about how we could simulate systems, real systems, quantum mechanical systems. He figured out that they would be horribly difficult to simulate and sort of model using classical methods. So he proposed, actually, for the very first time, that you should be able to use quantum mechanics itself to actually model such systems. And as a result, Feynman is considered to be the, at least, philosophical father of quantum computing. He did not do any quantum computing work himself, but he gave this basic idea that this can be done. And the reason why this can be done, the groundwork was, of course, laid decades earlier. Now, how many of you know what this equation is? Of course, it says almost that somewhere. It's a Schrodinger equation. Okay, by the way, let's just take a poll. What do you think is the most famous equation in physics? Let's take a poll. E equal to mc square.
Raise your hand.
Raise your hands if you feel E equal to mc square is the most famous. Okay. Quite a few people have not raised their hands. Okay, and how many of you would say Schrodinger equation is more famous? Not very much. Well, if it's not more famous, it should be. It's just that it's difficult to write that equation on a t-shirt. E equal to mc squared, you can make all kinds of means like ma squared, cut it out, write mb squared, then write mc squared and all kinds of stuff. You can make all kinds of jokes about it. E equal to mc squared happens to be a rather small sidelight of relativity. It's not really its most important aspect. It's not that important at all. It happens to have extra glamour for two reasons. One, it's easy. You can put it on a t-shirt, as I said. And also it has the glamour of the atom bomb. But the Schrodinger equation actually describes almost everything. So unless you go to very, very fast moving electrons and protons, Schrodinger equation is what would describe everything in the world. So that's way more important than E equal to mc squared would ever be. But what is very important for us is this issue that this phi, the wave function, has, okay, I mean, when I first gave this lecture, I made a point to memorize how this particular name is pronounced. I'm not going to try to make myself a fool out of myself by trying that again. Anyway, this basically is the famous paper in which Schrodinger talked about his famous cat. The idea was, in quantum mechanics, the wave function psi could be a superposition of multiple states. And depending on what kind of experiments you do, you end up with seeing either this or that. Now, this superposition, the ability for a system to exist in multiple states essentially at the same time, is what gives quantum mechanics its huge computational power. This is one of the basic cornerstones of quantum mechanics. But if you think about it, it's really very, very simple. It says that the theory is the simplest kind of theory possible, a linear theory. A theory where if U is a solution and V is a solution, then U plus V is also a solution. That's why superposition works. That's why it works with waves, for example. That's why it works here. Okay. So ultimately, the simplest mathematical structure possible gives rise to this hugely unusual behavior which quantum mechanics shows. And so this qubit is the so-called quantum bit. You all know that in computers, you measure things in bits, right? Zeros and ones. Qubits are systems which can stay in two states, one of which you could call 0, the other you could call 1. But the general state would be a superposition of 0 and 1. 0 into something plus 1 into something. And the fact that it can exist in a superposition of arbitrary number of states, because depending on the coefficients, you could get any state you want, within reason, of course. This gives computers based on quantum mechanics immense power, the so-called quantum computation supremacy. That's not my topic today. My topic is how to beat the quantum supremacy. But let me just point out one thing. The reason why RSA, which was based ultimately on factorization being very difficult, is threatened by quantum computation is because of this person. Peter Shor came up with an algorithm which allows us to factorize, using quantum mechanics, factorize large numbers in reasonable amount of time. Doesn't take age of the universe. Okay. In fact, this is I'm pretty sure this is just essentially to show off, right? I'm pretty sure nobody understands what this is, or some of you might. But this is basically what the so-called Shor's algorithm quantum computation circuit, the gates look like. Anyway, again, this is not my topic, and it would have taken me 3 or 4 classes at least to talk about it, or even more. But this is important. So Peter Shor and his wife Jennifer, in one of the scientists are really rather comical people. They're not really very serious. So this is one of the conferences on quantum computation, one of the very first conferences that took place. Jennifer and Peter Shor wrote this limerick. If computers that you build are quantum, then spies of all factions will want them. Our codes will all fail and they will read our email till we have crypto that's quantum and don them. Crypto that's quantum is my topic today. Okay. And one thing has to be mentioned that, okay, that's in fact in the return limerick. So Volker Strassen was another person who attended the same conference. And after Jennifer and Peter Shaw wrote this, he came back with this. To read our email, how mean, or the spies and the quantum machine, be comforted though they do not yet know how to factorize 12 or 15. Because the number of bits quantum computers then could handle, actually, were only 2 or 3. Now things have improved a lot. After all, if you open your newspaper, you will find statements about Google or some other company doing something great there. Still, they are not, the quantum computers today are not good enough to break RSA, at least commercial RSA, as far as we know. I'm saying as far as we know is no, because after all, if somebody manages to break the code, it will be to their advantage not to let people know that they have broken the code, right? If people knew that somebody else can break our code, they will not stop using it. They will not be able to get any information out of that. Okay, so we don't know for sure whether we know about quantum computers in the public domain, but we don't know about what's happening in the, say, military domain. The different armies have their own quantum computation teams who are trying to improve this further and further. So I don't know whether people have already managed to break RSA. That's very unlikely. But given the situation, maybe within 10 or 12 years, they will break it, definitely. And that seems like a very problematic thing. Strassen was saying only factorize 12 or 15, but that's really not the case today. Today, our quantum computers can actually break around 15-digit semi-primes pretty easily. Now, 15 to 200 is, or 400 is a huge gap, but unlike in the classical case where the thing scales that badly, here it doesn't. Here, if you can do it for 15 bits, once you can manage to conquer the technicalities, it should be doable easily for even 400 bits. The technical issues, like whether you can actually manage all these qubits without them interacting badly with the environment and breaking down and so on. Now, some of you might think that, after all, what's so important? After all, factorization is fine, but these codes, what do we care? After all, we don't have any secrets. Actually, you do, right? Every time you log into your account, use a password. It's encrypted and then sent over the mail, right? Every time you do a banking transaction, you send an encrypted message. Now, I'm not saying that everything uses RSA, but everything uses variants of RSA or something similar. Okay. So if that falls, our commerce is going to simply stop. If nothing else, there will be many other things that will be hampered, but banking system will completely collapse if this coding were to fail. So you have to understand that it's not just a matter of spies who are trying to send secret messages. We do that all the time. Our modern life is based on that. Sometimes, very often, we do this without even realizing that we are sending secret messages. Okay. So if you open WhatsApp, for example, nowadays it says end-to-end encrypted, right? Of course, you don't do the encryption. WhatsApp, the algorithm does it for you. But, okay, how long do I have? No, there must be some end in sight, right, for these people. You have done. Okay, 40 minutes. Oh, 20 minutes. Take it. Okay. Don't give me much more time because I can keep on going forever. Okay. So as I said, Strassen delivered his limerick 20 years ago. Today's quantum computers can handle up to 1,000 qubits. So that's way more. And RSA will definitely fall, if not today, in a few years. But the important thing is that quantum itself gives us back a way of encrypting, which is completely unbreakable. So this is my attempt to sort of quote from the Bible, which of course is the other way around. The Lord giveth, the Lord taketh away. But in this case, the quantum has taken away from us or will take away from us our ability to encrypt. But it will give us the ability. In fact, it has already given us the ability. Unlike quantum computation, which is still not very practical, as you will see, quantum cryptography the opposite end, is actually very practical. Now, I think I can not stop share. I can hide this, right? Okay. Now, way before all these fancy things came about, or way before RSA and so on. In fact, this fellow Vernam was in the 18th or 19th, early 19th century. So way before that, we had one code which could simply never be broken, the so-called Vernam cipher, also called one-time pads. This is something which nobody can ever break as long as certain conditions are met. So let's talk about how this is done, how one-time pads work. Now, nowadays, of course, all messages send digitally. And as you all know, every message is strings of zeros and ones, right? Ultimately. So let's assume that our message has already been converted to a string of zeros and ones. And the two parties who share this secret message, in this case, they are invariably called Alice and Bob. Well, A and B sounds too impersonal. So they're called Alice and Bob. And we begin by assuming that Alice and Bob share a key, a random key, random strings of zeros and ones, which is identical. They share it. They have the same ones and zero sequences. And this key has to be at least as long as the message that is being delivered. So let's say this is the key, and then you have the message. So this is just an example. You have this key and the message given. So how do you encode using this random key? Now, again, since there are school children here, I'm pretty sure many of you already know this. Do you know what the XOR is? XOR operation? If you take two bits, bits can only be zeros or ones. Okay. If two inputs match, you're going to get a 0. Only when two inputs do not match, you get a 1. That's an exclusive OR. In Boolean algebra, you have two kinds of OR. One is called the inclusive OR. When the output is true, if either of the two inputs is true or both of them are true. And the exclusive OR is true only when only one of the two inputs is true. Exclusive, only one of them. Okay. So now, all you have to do is take a look at what's happening here. So now that you have a key and the message, what's the cipher? Cipher is the coded message that you're going to send. So what you're going to do is a bitwise XOR. So what does that mean? It means that you take the 1 and 0, the first two bits, you can XOR. So what will that be? 1 and 0? As I said, if they have to be different, if they're different, the answer is 1 or high or true. If they're the same, the answer is 0. So 1 and 0 gives you 1. 0 and 0 gives you 0 because they're the same. Not because they're both 0, but because they're both the same. 0 and 1 again gives you 1. 0 and 0 again gives you 1. Sorry, 0 and so on. So this is the whole cipher. You can easily verify that this one is correct. At least I hope I have not messed up anything here. Now, this cipher is the message which is sent to Bob. Say Alice is sending the message. She and Bob both have the key. The random key is available to both of them. Alice creates the message. Of course, Alice's computer creates the message really. And a bitwise OR is done. And that bitwise OR results in the cipher text, which is sent to the recipient, in this case, Bob. Now, how do you decode this? Now, I'm pretty sure many of you already know this, but some of you have heard about the XOR the first time. May not know about this, but I would urge you to think about it and figure out why this is true, especially if you have not heard it before. If you do XOR twice, it cancels out. That is, A XOR B XORed with B is the same as A. So you took the key and the message, did a bitwise XOR, found the cipher. Remember, both Alice and Bob have the key. So what Bob has to do? Just take the cipher and use the key and again do a bitwise XOR. And notice that what you are getting back after this is exactly the so-called messaging. That's the plain text. So A XOR B is A. That's a very standard result in Boolean algebra. But you don't need to know any Boolean algebra for this. Just think about it, that if two things are different, only then you get a high, otherwise you get a low. Just use that idea. You should be able to figure out why A XOR B is back to A, always. Okay. So since both Alice and Bob shared the key, it's fine. They will be able to, Alice will be able to encode, Bob will be able to decode. Now, what about anybody else? Suppose somebody else intercepts the message. Can that person decode? I'm going to say, can she decode? Because unfortunately, it's a bit misogynistic, but the person who sits in the middle and tries to snoop in this subject is always called Eve. This is from the term eavesdropping, basically. So Alice and Bob are the players here. They are the ones, legitimate people. Alice wants to send the message to Bob, and Eve is the person who is sitting in the middle trying to get the message. Now the point is, the key is completely random. Right? This key has a strings of ones and zeros, which both Alice and Bob share somehow, but it's completely random. Which means that apart from the length of the cipher, if all that you can say from if you intercept the cipher, all that you can say from that is that the message is as long as the cipher text, has as many bits as the cipher does. But which one is 1, which one is 0, you have no way of decoding because the key could have been anything, right? So this is what is meant by provable security. Unless the key itself is somehow compromised, this can never be sort of tapped into. So one-time pad encryption is provably secure. Now, this has nothing to do with quantum mechanics, right? This is old stuff, really 200-year-old stuff, actually. So if this is so secure, why would anybody bother using anything else, like, say, RSA? The answer is the one problem which using one-time pads have is that Alice and Bob, for each message that they have to share a random key. Okay, which means this is why they're called one-time pads. You have two identical pairs of random numbers. Alice takes a look at the top page, uses that as the key, and then tears it off. Doesn't use it any longer. Bob uses the first page to decode, then tears it off. Then uses the second page for the next thing. The only problem is physically getting this key from one place to another, or sharing them without getting intercepted, is actually quite difficult. Delivering the pad and also keeping it secure. In fact, lots of people have tried very, very clever ideas for this. For example, this is a genuine thing. This is a real thing from a cryptographic museum. The random key is in that paper, is a microfilm, which has been, not a microfilm, but a developed microprinted thing, which has been put inside a walnut kernel and was smuggled with the walnuts. And of course, it didn't prove to be that secure because people managed to catch it. And what is important is to be secure, the key has to be known only to the legitimate parties. If anybody else knows it, they will be able to solve any message, right? And used only once, which makes it a hugely problematic thing to use, because every time you send the message, you need a new one. If you use the same key to send the same message or send different messages over and over again, then by using things called frequency distributions, etc., the fact that E, for example, is the most commonly used letter in English, TH is a very common diphthong, double letter, and so on, people can actually decode messages. In fact, not only that, it's not only that they can, they did. In fact, Soviet intelligence actually allowed the American Venona project. Venona project was manned completely by women, actually. So they managed to decrypt many of the coded messages which Soviet Union was sending at that time, which essentially was the real reason why the US ultimately ended up getting an upper hand in the Cold War. And because without that, it would have, this Cold War and the Berlin Wall and everything would have continued for a long, long time more. Now, our main point is, how does quantum help us here? Okay. So what we need is not really a way to encode. We already have a way to encode. What we need is a way to securely distribute a random key between two legitimate parties. Legitimate parties should be able to get it and has to be securely done, right? Now, an eavesdropper should not be able to intercept the key. And more importantly, any attempt to intrude into the communication of the key, that should be detectable. That is, the legitimate parties should be able to figure out that somebody is sitting in the middle and doing that mischief. Of course, if you know that somebody is doing mischief, you will not use that particular key, then you will just use something else. But if you don't know that your key is compromised, then it's very dangerous for you. Okay? Now, I've been naming this topic a couple of times before. I've called this quantum cryptography. That's actually what it is very commonly called, but that's a wrong name. It's actually quantum key distribution. You don't do cryptography using this. You don't encode or decode using quantum. You send the key from one person to another. You distribute the key using quantum mechanics. Now, since I'm short of time, I will skip on the history a bit. Well, just one thing, Stephen Weisner came up with these ideas in the 1970s. And, well, almost nobody listened to him. So those of you who are in college and have studied quantum mechanics would know even in today in college, what we usually do is solve eigenvalue equations for the harmonic oscillator or something else. We don't really pay too much attention to how measurements are done and so on. But nowadays, this is the most important topic. In Weisner's time, nobody really listened to him much. In fact, despite the fact that he did the work in 1970s, his work got published only in 83. So 12, 13 years was wasted in between. And the very next year, these two people, Charles Bennett and Giles Prasad, used Weisner's ideas to propose the very first quantum cryptography protocol. The way to distribute keys using quantum mechanics. This was called the BB84. Now, no prizes for guessing why it's called BB84. B for Bennett, B for Prasad, and 84 for 1984. And in a few years' time, Bennett and Lee Smolin, an experimenter, they teamed up and they actually practically did the first quantum cryptographic key distribution. Quantum key distribution practically. They did it only over a long table. So not really very practical from one end of a table to the other end. But the idea was this can be done. That was demonstrated. And some of you may have heard of this entanglement as being one of the most important things in quantum mechanics. I'm not going to talk about that, but entanglement is also a very important resource which can be used in quantum key distribution. And Arthur Eckart was the first person, again 91, so E91, who used entanglement to send keys from one place to another, at least figure out a way of sending keys. And okay, this happens to be the only original contribution I have to this talk, these two pictures, because when Bennett came here in Calcutta, I've forgotten the year, but maybe, okay, I can see Prashant, my colleague here, who was a lot younger then. So maybe 10, 12 years ago, maybe. So my only original contributions are these two pictures, which I took then. And you can see our institute's logo in the days. So that's some advertisement for us. Okay. Now, the B92 protocol is what I want to describe to you in 10 minutes. Hopefully, it should be done. It's not very difficult to understand, but you need background in one thing, which is something called polarization of light. Is there anybody here who does not know what polarization of light is? You can, of course, say that. There's no harm in saying that. If nobody is saying that they don't know, I'm going to assume everybody knows, which means that I will be able to sort of skip through this. You know what we are talking about, right? Two polarizer sheets, you turn them around and the light dims, and when they're exactly perpendicular, it becomes completely black. This is the way polarides work. And the question is, why does it work? Now, from the wave theory, we know this, that there are specific So first of all, light is a transverse wave, which means that when it's traveling in this direction, the electric and also the magnetic, but let's focus on the electric field points perpendicular to that. Could be in any direction perpendicular to that. Right? There are infinitely many possibilities. But as long as you're perpendicular to a given direction, you can break it up into two components always, right? Either this or this. That all of you know. So here the idea is the first of these is called a polarizer. And let's say it has an axis which only passes the horizontal component. That's basically what a polarizer is. It blocks one component, passes the other one. So once it comes out of the polarizer, so the light is polarized this way. The electric field oscillates in this direction. Of course, this is the electric field at a particular instant of time. It keeps on oscillating. So it not only points in this direction, it goes back and forth. But now when you have a second polarizer, which you call the analyzer, that's the technical term for it, at an angle, then only one of the two components, the component along this dashed red line, that's going to be passed. The other component will be blocked. That's how a polarizer works. So basically, as you of course know, if the angle between these two lines is theta, the electric field component is just cut down by a factor of cosine theta. And since the energy is a square, proportional square of the electric field amplitude, you get what is called something called Malus's law, which I'm pretty sure many of you have already studied, which is I equals I0 cosine square theta. Let's just check one quickly. Theta is 0 means I equals I0. So if both polarizer and analyzer is in the same direction, then after it passes through the polarizer, there is no further diminution when it crosses the analyzer. On the other hand, if theta is pi by 2, then cosine squared of pi by 2 is 0, which means that if the polarizer and analyzer have perpendicular axis, light will be completely blocked, as you saw a while ago. Okay. Now, in particular, we are going to focus on diagonal polarization in the rest of the talk. If the angle is 45 degrees between the two, or 135 degrees actually, then there's exactly 50% of the intensity which gets passed through, right? Now, how do we understand this? In terms of classical wave theory, it's pretty easy. This is just exactly what we say. One component passes, the other component gets blocked. On the other hand, we also know that light is actually a stream of lots and lots of photons, right? So how do we understand this from the photon picture? Now here the idea is that, again, what you would say is, if the polarizer and analyzer are at 45-degree angle, then half of the intensity gets through, but the color doesn't change, the frequency doesn't change. That means the photon wavelength, photon frequency stays the same. Energy of each photon, I'm pretty sure all of you know this, right? H nu stays the same. So why does the intensity become halved? Because half of the photons go through, half of them don't. Now, this is where quantum mechanics comes in. This is completely probabilistic. There's no way you can tell beforehand whether a particular photon is going to go through or not. All you know that is, if you send tens and thousands of photons, roughly half of them will go through, other half will be blocked. Okay. Now, and what is very important is once it goes through, the photon state changes. So if you look at the previous example, after it goes through, the photon state becomes polarized in the direction of the red arrow. Okay. So whatever state it was before, it doesn't stay that state unless, of course, the red and the blue arrow coincide. So this is what in quantum mechanics we call the collapse of the wave packet. It simply means that the polarization state depends on the last polarizer, whatever was state used. Now, I will just ask you to pay a bit of attention with this. I'm not going to repeat this, but okay, the B92 protocol is not the best quantum cryptography protocol. There are much better QKD protocols, much more effective ones. But the B92 protocol is very easy to understand. So remember, the aim is ultimately Alice and Bob must share the same random key. Has to be random string of zeros and ones, but both must have the same thing. Okay. So what they do initially is that they, or rather their computers, come up with completely random strings of ones and zeros. So Alice has a string, Bob has a string. Now, of course, you can easily see that the chances of these two strings being identical is nearly zero, right? One match, 50% chance. Two matches, half square. Three matches, half cube. And if it's, say, 1,000 of bits, half to the 1,000 is a chance of there being identical by chance, which is almost zero. So these two strings are completely different from each other. Of course, they match somewhere. They would by chance. They also don't match in other places. The aim of quantum key distribution, at least of B92, is to somehow manage to identify those which match, at least part of those which match. Let's see how they do it. So Alice has a job of sending out photons. So Alice looks at her string, ones and zeros, and if her string is zero, her bit is zero at a particular position, she sends a horizontally polarized state. Okay, a photon polarized in this direction. And if it's one, it may seem natural that he will send it like this in the perpendicular direction. He doesn't. She sends it at an angle, at 45 degree angle. So two things, one at 0 degrees, the other at 45 degrees. Now, what Bob does is Bob sets his polarizer, looking at his strings of zeros and ones. So when Bob's bit is zero, he actually places his polarizer axis diagonally, okay, at an angle of 135 degrees to the horizontal one. And if it's one, he sets it vertically. So can anybody see what's the connection between these two things? Say, if Alice and Bob had different bits, let's say 0 and 1. So Alice would send a horizontally polarized thing, and Bob would set his polarizer vertically, right? That means what is the chance of that photon going through? At 90 degree angle? 0. There's no chance of the photon going through, absolutely. Okay. That's true for 0 and 1, also true for 1 and 0. Okay. So if Alice and Bob have different bits, they will definitely not be able to. But Bob will never be able to see a photon which goes through. Well, if they're the same, suppose both of them are 1. Then Alice sends it like this. Bob tries to measure like this, right? Alice's photon is polarized at 45 degrees. Bob is measuring at 90 degrees. So the angle between the polarization axis of the photon and Bob's polarizer is 45 degrees. So what's the chance of the photon going through? We already talked about this. Cos square of 45 degrees. How much is that? Half, 50%. The important point is this, that if light doesn't go through, it could be either due to the bits being different, or it could also be because the bits are the same, but there's this 50% chance, which didn't allow us to get this. Okay? On the other hand, if the light goes through, then they must have had the same setting. Okay? So what does Bob do? He keeps on looking at Alice sends one photon after another. Of course, all of this is done automatically. Bob keeps on seeing whether the photon is going through or not, just keeps track of which photons are going through, the numbers. So at the end of the day, what Bob can do is tell Alice over the phone or by advertising in a newspaper or wherever that the third one matched, the fifth one matched, the ninth one matched, the 11th one matched. Note that nobody other than Alice and Bob have access to their strings which are in their computer, okay, which are secure with them. That's not being sent. So if Bob says openly that the fifth one's a match, well, even if everybody else knows this, that will not give them any information, right? Now, since I don't really have much time, the interesting part would be what happens if Eve tries to break in. But I'm just going to skip that for the time being because I want to talk about current scenario. So this is what we have talked about. So this is the eavesdropping part, which we will discuss later if somebody wants to know. And then question is, is this reality or is this science fiction? Well, it's already reality. Bennett and Smolin did this in 89 and then again in 91 over a tabletop. But in 2009, a collaboration between universities of Cambridge and Toshiba achieved a secure key distribution at 1 megabits per second over 20 kilometers of optical fiber. So not a small distance any longer, not a tabletop. Well, things don't stop here. Well, using the E91 scheme, free space QKD without using any fibers or anything to transmit the photons was done over 144 kilometers using BB84. That's the original Bennett and Bassard algorithm in 2007. So that was already done in 2007. So that's nearly 20 years now. Well, in 2017, Phases managed to actually send the signal from ground to a moving aircraft, which of course is extremely important because for military applications, of course, you would want to do that. And then you have the Quest space mission, which has managed to communicate from China to Vienna. So that's a huge, huge distance using a satellite, again in June 2017. Now, what about us? Are we too far back? Okay, anyway, let's just look at, these were lab examples, but what about real world examples? As I said, bank transfers need coding. So Vienna was the first place where coding was used to send, quantum coding was used to send signals in 2004. Well, it was even more than that. The 2007 Austrian national election results were actually communicated using quantum cryptography. So quite important daily life things have been done. And okay, there are many of things. And 8 companies offer commercial QKD kits today. This was created maybe 2 months back. Maybe things have increased beyond that. One of these companies happened to be in Bengaluru. And many more companies in India are doing R&D for the soon-to-come versions of commercial QKD kits, which you can buy. And what about India? Well, in 2020, Indian Defense Research and Development, DRDO, tested QKD between its 2 laboratories. March 21, free space quantum computation over quantum cryptography, communication, over 300 meters. This was done by ISRO. 2023, rather recently. IIT Delhi and has achieved QKD of up to 380 kilometers. But what actually takes the cake is not this one, the next one. Last month, June 2025, the IIT Delhi group announced that they have been able to establish free space QKD without any fiber or anything, just through space. A link over a kilometer at a speed of 240 bits per second, which is quite high. It's one of the best in the world now. And with a quantum bit error rate of only 7%, which is actually quite good. So this has been announced only a month ago, less than a month ago, actually. It was near the end of June that this was announced. And so India is making huge strides in this. And finally, if you want to read a bit more, okay, the last one is for anybody who wants to read Edgar Allan Poe's mystery stories. Well, there are books which you can read. And apart from anything else, I would definitely recommend the very first book for everybody. Doesn't matter whether you're in school or college, or doesn't matter where you are and what level you're studying. Simon Singh is one of the best communicators we have had for a long, long time. This code book is a treat to read. So there's lots of intriguing facts and quite a lot of masala in it. But anyway, if you are interested in the masala, you should read it. If you're interested in the substance, you should definitely read it. And as I said, cryptography is strongly mathematical. So many of these are number theory books. Okay. So if anybody asks what do mathematicians do for our daily lives, they keep our world secure, if nothing else. And the last 2 happen to be dealing specifically with quantum cryptography. Okay. So anybody who is interested, but for that you will need to do a course in quantum mechanics first. At least some linear algebra, some quantum mechanics. This is not very difficult to understand, but it takes some effort. We're doing this the first time. Okay, I think I'm done. So if there are any questions, I can take that on.
Such an thought-provoking and fantastic lecture by Professor Ananda Dasgupta. I think you have lots of questions, students. Please feel free to ask.
So if there are no questions, it usually means that either the talk has been wonderfully good, that nobody has any questions, or has been so bad that nobody has understood anything.
Don't hesitate, student, please.
No, that's one way to force people to ask questions. If you say that,
What is superposition?
In quantum mechanics or factorizations, qubit.
so that's a question which school students will have very difficult to answer.
Superposition, I mean,
But at least light interference, you have studied that, right? You have seen superposition there. Haven't you?
বাংলা মাধ্যম থেকে যারা এসেছো তাদের কি কোনো অসুবিধে হয়েছে? না তো? যদি মনে করো তোমরা যা
আমি বাংলাতেও বলতে পারি।
হ্যাঁ স্যার অলরেডি বলেছেন। If I'm not wrong, you can also listen to him in Bengali version also in his YouTube channel. If I'm not wrong, sir,
I think there's a recording of this in Bengali.
Yes, yes.
Of course, that's more detailed. That has also the eavesdropping part. Bolo.
Well, in bank interference, how can we use cryptography?
Bank interference. You mean?
Yes, sir.
You mean when you send the message from one bank to another?
One bank to another, like.
Right. So cryptography is used whenever you want to send a message which nobody else will be able to read.
Yes.
Right. So basically what you do is essentially you encode the message into a ciphertext. Now, how you do that depends on the specific way in which
So yes, because bank has a very high capsulated data.
Right, but the highly capsulated data actually is a very standard strict format. So it's very easy to actually encode that into using a particular code.
Okay.
And the important thing is, as long as you're using a complete, say, if you're using the Varnam cipher, the one-time pads, if you're using, or quantum key distribution, which is essentially using one-time pads, if you're using the same ones and zeros for both, then they're the only ones who can send and read. Nobody else can send and read.
Okay. Thank you. Let's have if you have further question, please raise your hands. If not, somebody?
এবারে প্রাণ করিবে দান তাহলে কালকে না উল্টোটা তা হয়
Let's have a big round of applause for Professor Dasgupta and his wonderful session.
Thank you.
Thank you so much, sir. But I should say it's a truly enriching talk, and I'm sure that it sparks a lot of curiosity among us. But definitely, you can go through the sir YouTube channel. You can learn something good. Actually, I personally follow his channel. Thank you so much. And there is an announcement before the lunch break for workshop session, which will begin. I think if you can start lunch from 12:30 around, then we can start workshop session at 1:30 p.m. Okay, so workshop on machine learning, the accompanied faculty members will be Dr. Tomal Kumar Mukherjee, Dr. Ritomay Bhuya, and Dr. Shatarupa Mishra. And venue is room number 2102, SOET building, that white one. And workshop on Arduino, accompanying faculty member will be Mr. Piyush Pallav, Sharatindu Samanto, Mr. Moik Sadhuka, and me, Dr. Papiyadhara, and it would be in room number 610 SOET building. So before going to the lunch break, we will meet just outside the building for a group photo. And please, all of you collect the receipt who have paid but didn't receive money. Please, before going to the lunch break, collect the receipt from that registration desk. Okay, and please, all of you, including our respected speaker, resource persons, all faculty members, please gather in front of the building for the group photo. And
Actually, there is raining, so we will call the schools one by one and take a group photo here.
okay, so here only we will do because it's raining outside. Okay, I couldn't understand it from here actually. Okay, and okay, after the group photo, we can go to the food court. There will be bus just in front, outside the building. So there will be two in the stage. So, can we call the school basis? I mean, maybe first row is the same school, right? First, I would like to request all students and faculty members, teachers is available from Adamas International School. Please come on the stage for group photo. And I would like to request all our respected speakers, my dear colleagues, please come on the stage for the group photos. Adamas International School. Students, please come.
Ma'am, please.
Professor Dasgupta, sir, please come for the group photo. Please, sir, take your seat on the stage. Professor Aparajita Bhattacharya, please, madam, take your seat. Motion, sir. Pradipta sir, please come on the stage. Dr. Adav, sir, please come on the stage. And all the faculty members, please, my colleagues, please come on the stage. Okay. Yeah, wait. Okay, next, Adamas World School. Please, come Bharu. World School. World School, please come. The Adamas International School, you can wait outside if it is. Okay, then sit here. Sit here. We can go together. The photo session. So, World School. আচ্ছা সামনে কেউ কয়েকজন বসে যান সামনে কয়েকজন বসে যান
সামনে কজন বসে যাও সামনে বসে যেতে পারো
yes because these students are not visible so some of you please come forward you can sit
Miss Bella taller than you. তোমরা সামনে এসো হ্যাঁ তোমরা সামনে এদিকে এসে যাও সামনে এসে যাও চলো যাও তুমি এই পরে বলো গ্রুপে শেয়ার করে দাও হোয়াটসঅ্যাপ গ্রুপে শেয়ার করে দাও
thank you so rest of the students please come
কোনটাই ক্ষেত্রমোহন সব
কোনটাই ক্ষেত্রমোহন স্কুল
হাওড়া সেন্ট জন
হাওড়া সেন্ট জন স্কুল
খালিসকোটা খলিশাকোটা আসছে মনে হচ্ছে এটাই হবে
খলিশাকোটা গার্লস হাই স্কুল
সমস্ত স্টুডেন্ট বাকি সবাইকে নেবে এদিকে এদিকে চলে এসো তো একজনের গ্যাপে একটু করে দাঁড়িয়ে যাও তাড়াতাড়ি
হ্যাঁ বাকি
এই সৃজনশীল এদিকে ডাকা হলো তো
yes students from Adamas University all students please come দেখাই যাচ্ছে না সামনে সামনে ছিল আমাকে এখান
এই দেখো ওকে দেখা যাচ্ছে না তুমি ছাড়ছো না এই অর্পিতাকে সামনে দিয়ে দাও সৃজন সৃজিত দুজনের গ্যাপে দাঁড়াও সবার ফেস দেখা যাবে দেখা যাচ্ছে এদিকে আসো এখানে